Okay, hey everyone, and welcome to my talk. My name is James Trott. I am a principal engineering lead at Microsoft, and previously, prior to my current role, I built some of the large enterprise services in Azure, and I'm now talking to people about how you as game developers can gain the benefits of years of enterprise R&D from some of Microsoft's biggest customers and leverage them in your own game development projects. And there's a dinosaur attacking the booth, apparently. So, I'm here to talk to you about containers, clusters, and the cloud specifically for gaming applications. If anybody's worked with Docker containers before, then this is absolutely for you. If you have not, then I will take you through what that means. When you think about gaming and you think about online gaming, you of course think about servers, and one of the things that we get asked a lot about at Microsoft is, hey, how do I take those online instances of my game, make them available in Azure easily? I'm not a big online guy, I'm not a big cloud developer, I'm focused on making the most fun experiences for my customers, for my gamers as possible. So I wanted to put something together and just show you guys how easy it is to get started with this technology in Azure. So that is the penultimate slide. There are very few left. This all starts with Docker. So Docker is a container technology not owned by Microsoft, and it is used to wrap runtimes and execute them containerized over a hypervisor on a VM. So when we talk about what is a container, I just used the Docker guidance, and as you can see here, you can place applications such as Tomcat, Java, Debian, PHP, MySQL, or your own gaming workloads, and you can put them above the kernel of the underlying OS. The cool thing about that is each container is individually isolated, and as such is protected from all of the other containers running on that infrastructure. It also means that it works on my machine is no longer a problem that you need to solve. If it works on your machine, it's using the same kernel link-up. All of your dependencies are inside of the container, and as such, it's all available to you. This is the difference between containers and virtual machines in the cloud. So as you can see on the right there, you've got the VM, it's running its app, it sits on a hypervisor over infrastructure. On the left, that same container is just running the app and your dependencies, nothing else. And that's why it'll always work on your machine and always work on our machines too. The dependencies are right there, side by side, next to your app, and everything else, the Docker, the host OS, the infrastructure that it runs on, is outside of the container being consumed from inside. So I'm just going to open up a couple of steps here, and then we're going to get straight into how easy it is to deploy this stuff. All of the information I'm going to share with you is available at docs.microsoft.com. As you can see here, we have documentation across the entire Microsoft product range available there. Everything I'm going to talk about has a tutorial and a guide inside of docs.microsoft.com. So first we're going to talk about Azure Container Instances. Container instances are a way to get started quickly using containers inside of Azure. You can spin them up very quickly and very easily. Then we're going to move on to talking about a fully managed Kubernetes cluster inside of Azure on AKS, our Azure Container Services, which is a fully managed compute cluster that you can scale to meet the demand of your player base. First, we're going to talk about what we're going to do. We're going to deploy some Minecraft. Minecraft is a game that Microsoft acquired Mojang, the developer of, just a couple of years ago. It's one of the most popular games in the world right now. And I want you to think about deploying Minecraft servers. What if you wanted to deploy multiple? What if you were in charge of that Minecraft project? What if you wanted to make hundreds of servers available for players to play on in a safe, closed, potentially protected, password protected, or private environment, and how you might turn that into a business model, renting out multiple servers. It's a business model today for an awful lot of companies. So this is Docker Hub, available at dockerhub.com, and you are able to select images from a library of your dependencies. There are a couple of games in there, database servers, anything you can think of that other people have taken and containerized and made available inside of Azure. Or any other cloud of your choice. Docker is cloud agnostic. It's a technology out there, originally from the open source and Linux communities, that allows this wrapping of apps and dependencies. And so the images that are available here are put together by other people and contributed. This is the one, the premiere image from Minecraft servers from a guy called ItzG. And if we take a look at the Docker file, you can see what's going on in here. So straight into the code, we'll take a look. This is from the Alpine Linux image right here. Calls out the maintainer, and then it runs a whole bunch of commands here that puts it together, installs MC status, which is a Minecraft modification, does a health check, and then adds a bunch of groups and security things. the underlying image actually installs a bunch of dependencies for Minecraft, and it has the option to pull in mods. ITSG has a very rich project on GitHub that you can go check out that allows you to customize your Minecraft server installs. So this is the image we're going to use. We're going to use this to deploy a Minecraft server inside of Azure, and we're going to do the whole thing here live. So the other thing I get asked is, how do I do it? Well, this is the Azure Portal, and many of you may be familiar with the Azure Portal. Typically, I prefer to do this with the Azure CLI 2.0. It's completely possible here inside of the Azure Portal to deploy services, deploy containers, deploy clusters. I prefer to do it at the command line. Many developers prefer to do exactly the same thing. However, today we're going to try something a little different. What we're going to do is we're going to try and do this in the command line inside your web browser. Just to prove that I'm not cheating, that is a copy of Microsoft Edge. And I just click the button that's going to request me a Cloud Shell window. This is a full Linux bash terminal running inside of your web browser on Azure. So once it's connected, it's going to request a session for me. And hopefully, it's going to spin up a live command prompt connected to my Azure Portal. So there it is, James at Azure. So we're just going to get a few things set up here. We just need a few little environment variables set. So we're going to do resource group name equals GDC -live. We're going to do region. We're going to pick our Azure region. I'm going to deploy these into East US. Now we're going to pick the name of our container instance. So we'll do instance underscore name, and we will use GDC-instance. Then we'll do the name for our cluster that I'm going to show you how to do. We're going to do GDC-MC from Minecraft. And then when we do the deployment inside of Kubernetes, we're going to need a deployment name. So I'm just going to call that GDC-Minecraft. All right, and we're all good to go. So when we think about this, the first thing I want to talk about is deploying a container as an instance. An Azure container instance is one instance of a container that you specify. This is your getting started scenario, and if you just want one server for dev test purposes, or perhaps you just want to spin something up yourself to kick the tires, I really recommend trying an Azure container instance. It's super straightforward to get started with. So we're going to try and do one live here. So the Azure CLI is automatically deployed inside of the Azure Cloud Shell and is used using the command AZ. So if I type AZ, I can see all of the services inside of Azure that are available to me through the command line. What I'm going to do now is I'm going to use AZ container. AZ container takes Azure container instances. I'm going to create one. I'm going to specify a name. And we specified earlier that our name was going to be $instance underscore name. We're going to do, oh, I missed a step. So we're going to have to do AZ group create. -- location equals $region. This is going to create us a resource group inside of Azure. -- name equals $RG underscore name. Fingers crossed. Provisioning state equals succeeded. That successfully created a resource group inside of Azure. And if you don't believe me, when I click this little refresh button here, or not, that's okay. If I come into here and type GDC on my filters, GDC-live, which was the name that we specified at the beginning. So we'll go back to my dashboard here, get straight back to what we were doing. So we're going to do, as I mentioned before, we're going to do AZ container create. We specified the name already, so name equals $instance underscore name. We need to specify the resource group that we wanted to deploy to. I already stuck that into a variable, so it's already there and available for me. So RG underscore name, that'll do there. Then we need to specify the image. The cool thing about the image tag in Azure container instances and container services is that it'll automatically check Docker Hub for the image as long as you name it correctly. So itsg/minecraft-server is the name of our image. Now we need to tell it that we're going to want an IP address. So we need an IP address, and because I want to be able to connect to my Minecraft server, I'd like it to be public. I need to specify a port, which for Minecraft is 255/65. And I need to tell the instance how many CPUs I want with --CPU, except I've used equals 255/65 --CPU space 2. And then I need to specify one environment variable that is essential for Minecraft, which is So environment dash variables space EULA equals true. And this tells Minecraft that I accept their end user license agreement and I am able to deploy this container. So it's a little lengthy there, but that one command, when I execute it, hopefully passes the parameter test, so fingers crossed once more. And provisioning state is now creating. Now, if I go back into resource groups where we were taking a look before, I type GDC-live, which is the name of my resource group, and I go into here. We hopefully see GDC-instance. So if I go into GDC-instance, you can see live in the Azure Portal working side by side with that Cloud Shell hosted inside the web browser. So we're still inside the web browser here. This is just Microsoft Edge. We haven't left and we haven't needed any other tool on the web browser. I could do this on a tablet. I could do it on any device with a compatible web browser. We can see the IP address is already here and ready. And I tend to find that game devs especially are very cynical of this particular demo. And so I just like to have Minecraft here waiting. So we're just going to call this ACI MC, put in the server address, not twice. Say done. Hopefully the little bars on the right are going to turn green for me, telling me that my server is available. There it is. And just in case you are still cynical in any way that I have not deployed a real live Minecraft server with the IP address to that resource group, we will log in. And there live is a Minecraft server capable of running 30 players with 2 CPUs live in the cloud from a Cloud Shell inside your web browser. Thank you, sir. I appreciate that. So that's super useful for your dev test scenarios. You're able to create that and spin up that server right there. You saw how long it took me. We've been in this like 5 minutes. We're in it together. We're going to get through it. It's fine. So I'm going to jump straight back out to my web browser. What about your scale scenarios? That's where we start talking about clusters. Maybe I want a cluster of multiple VMs running multiple Minecraft servers. You can actually run a couple of Minecraft servers just on a very low-powered VM. 2 CPUs, 16, 32 gigs of RAM will run a healthy number of Minecraft servers. So you can spin them up. So what I'm going to show you how to do now is create a cluster of VMs controlled and managed by Azure Container Services, AKS, inside of Azure. And I'm going to show you how to deploy to that. I'm going to show you how to scale it, and I'm going to show you how to configure it to scale itself based on utilization. And I'm going to do it all from a Cloud Shell inside of a web browser. So bear with me. Sometimes it goes a little wrong, but I've prepared. I've got backups on my backups. I think we're going to be good. So we've already got our resource group and our variables, so I'm going to do AZ-AKS. Note that I am not typing AZ container. AZ container is for Azure Container Instances. AZ-AKS is specifically Azure Container Services. So I'm going to create, just like last time. It's a very similar syntax, and we try to make sure that it's fluid and all the same. I'm going to use a name, and if you remember, my name is cluster_name. The dollar is a variable. I stored it at the beginning, so for those of you that came late, they're all stored. I'm not cheating, I promise. The gentleman in the front row can tell you I typed it all. So there's our cluster name. We're going to do our resource group, which you'll remember from before. We're going to do $resource, RG_name. That was my resource group name. This is a cool little flag that AKS supports, --generate -SSH -keys. How many of you have deployed VMs before, especially Linux VMs, and then had to that whole dance with getting the keys, setting your certificates, and matching them up? If you put --generate -SSH keys into the AKS command line and you do not have an SSH key already available, it will create one for you, put the public keys into your ./RSA folder, and then it will configure your cluster to use that key. If you already have an RSA key, it will use that one by default. I'm in the Azure Cloud Shell, so I don't have an SSH key, so it's going to generate that for me. And the Cloud Shell is really cool. It generates a disk live on blob storage, a storage account inside of your Azure subscription, uses that blob storage as persistent storage. So if I close this shell window and then I come back, the same SSH key is still there and I can still connect to all the services I created for it, hosted, backed up, globally available, live in the cloud from my web browser. You can grep it down, you can email it to yourself, you can access the blob storage disk and download the actual file. Can I actually SCP from my terminal to the cloud terminal? You can absolutely you cannot SSH into the cloud terminal, but you can access blob storage using either the blob storage SDK, or you can access it directly, you can access it through the web browser, or you can send it to yourself. You could FTP it, you could send it to a VM, so you can SSH into a VM box from the Cloud Shell. You just SSH from the cloud into your box. and then you can put it into there. You can use this. Blob storage is available like a file store, so you can just go grab stuff out of it. So the key is completely accessible. What I would recommend doing is sending your key into Azure and then consuming that. You have your keychain, your YubiKey, whatever you want to do. I would just use the same key and then just have different ones for different infrastructure levels. Your dev keys, your test keys, your deployment keys. And then lastly, I'm going to use this --no--wait. So one of the things that takes a little time is standing up a bunch of infrastructure. We have a very short time here today with you at GDC, and I want to give you as much value as possible, so I'm not going to make you wait for the cluster to stand up. --no--wait says don't wait for any long-running operations to complete before you give me the shell back. So I'm just going to run it like that. I've got the name, I've got the resource group, I've got the keys, I've got no wait, I'm going to run it. We're good. So any second now, it's going to come back and it's going to give me that JSON result. And you notice it's always a JSON result. So these bash commands can be executed remotely. So because it's no wait, it doesn't give me the JSON result. I forgot that. My bad. I'm sorry. But if we go back to my resource group, GDC-live, and then I refresh this, there's GDC-MC. That is a live Kubernetes cluster running, spinning up with a bunch of nodes. Now, one of the things I just want to note for you guys is that when you do this, when you go out to resource groups, when I do this, excuse me. When I refresh this list, eventually there's going to be a second resource group called GDC-live in there. And you can see this with this one that I created earlier that's super handy called GDC Pre. So the live one is live and the pre-made is pre. We're all open here. So with GDC-Pre, which I have this handy Ubuntu shell running in Windows. So this is pure Windows. This box is a pure Windows box. This is the Ubuntu Windows subsystem for Linux running inside of Windows. And I already have a cluster here called GDC-Pre. So while we're waiting to deploy, I can show you some neat things about Kubernetes. So one of the things you can do is, you'll notice that the AZ command line is running inside of here. Like so. And I already have all of those same services that I had in my Cloud Shell. Now, if you do az aks install -cli, it's going to think for a little bit. Oh, sorry. Sudo az aks install -cli. Little password here. Don't say it out loud like I did last week. Just joking. I would never do that. This will download the Kubernetes client. It's called kubectl or kubectl. It downloads it and make it available. So now as soon as I type here, kubectl, there it is. Now, I already cheated. Pre already has a Minecraft server running on it, so I do kubectl get nodes. And there are 3 already running in GDC-Pre. There's already 3 AKS nodes running. If I do kubes, that's the number of VMs running underneath. So those are individual DS2v2 VMs in this case running AKS, and they're ready to receive pod loads. If I do kubectl get pods, no resources found. This is where we want to be. So it's a 3-node cluster ready for me to do something with it. So what we're going to do is we're going to deploy Minecraft to this thing. So kubectl is already connected because I got the client, and just for those that wish to know, in order to set up kubectl to connect to my cluster, it seems like it's a little magic right now. It's automatically connected. I just need to do a quick command line az aks get -credentials --name equals $cluster -name. Sorry, that's cluster _name, and then --. I've lost my place. Oh, there you go. -- resource group. Stupid. -group equals $rg_name. That's okay, I already ran it because you can already get connected. So this is just for your reference. I don't actually need to run it. The typo is good. Otherwise, I'd have gone back and done it. So that's how it's connected. And what that does is automatically downloads the credentials for that and connects kubectl to it using your RSA key. So now we're hooked up, ready to go. So quickly, we're going to do kubectl run GDC - no, that's right, yep. We're going to run an operation that we're going to call $deployment _name. That's good. We're going to do dash dash image, it's G / Minecraft, dash dash port. Everybody remember the port from Minecraft? 25565. And then dash dash n for those environment variables that were essential last time, equals EULA equals true. And we're good. GDC Minecraft is created. I'm now going to do kubectl get pods. Pods are the individual running. Oh no, the internet is no longer pulling my image. Let's just double check this. It's okay, error between keyboard and laptop. Keyboard and chair. Of course. So we're just going to quickly edit my deployment name because now it's errored. It's using my variable, so I'm going to do deployment underscore name equals GDC Minecraft 2. Bingo. kubectl get pods. Container creating there on the second line. Meanwhile, while I'm doing this, I'm just going to quickly clean up after myself. Do kubectl delete pod deleted. Get the pods. Containers are creating across the board. So we wait until one is created. So this one here is running. The last step for this, you may remember I had to specify an IP address when I created an Azure container instance. So all we have to do here is expose the service. It's just exposing it on the edge of the resources that we created. So we just do a quick kubectl expose deployment, and I believe we called our instance this time GDC-Minecraft 2. Dash dash name equals Minecraft-service. That seems fine. And then the type is really important. So I want to call this out. I'm going to use type equals load balancer. That will load balance between my services. So every player that connects will just get a server. It'll just go around and it'll connect each one. So there's another option called node ports, which exposes each one on a different external port to the internal service port. We're going to run this up. Services exposed. We do kubectl get services. And it's already running, and you can see here, external IP pending. That is waiting for an IP address from Azure, just like it was in the portal. It's requested a public IP, and it's waiting for one to provision. Now, hopefully, this is going to work super quick for us. One of the things we can do is kubectl get services -- watch. That's going to run it, and it's just going to sit there, and when that IP address comes in, it's going to give me that new line and say, hey, your IP address is totally available on it right now. I'm running close to time, so I'm going to get about 30 seconds. If it doesn't come up, then we're going to move to a different one, and I'm just going to show you how to manage your deployments when they're live. Doesn't look like it's going to give it up. One of the things we can do briefly is just quickly check the portal. So we can go into GDC Pre, where I was working, my pre-made cluster. And we can close my Cloud Shell because it's all going to be there for me when I go back. We can check the resources and no pools. Ooh. That's interesting. It's in a failed state. I guess we'll go back and check that later. So, in case of emergencies, I have one more resource group backed up with a cluster called GDC-MC-test. And if you remember before, we were talking about kubectl get-credentials, AKS get-credentials. Yep, -- name equals GDC-MC-test -- resource -group equals $RG_name, because it's all inside the same resource group. It's not GDC-P. We just got out of that. It's GDC-dry from my dry run. Merge contacts, kubectl get nodes. You see it's a 5-node cluster. Kubectl get pods, there's a Minecraft server. The Minecraft server is there, is running. If I check kubectl, get services. Oh, there you go. External IP. I'm not going to log into this one, but I am going to show you that it works, because we've had to switch to the backup, but it's a real Minecraft server. It's really running. It's really running inside of that 5-node cluster. See, one live Minecraft server, 0 players. So two last things that we're going to do. What about if I wanted more? I'm a game dev and my server is full, it's launch day, everybody's been in that scenario, it's a super popular game and they don't have enough capacity. What would I do in this scenario? I might type a lot of code, I might have to provision new hardware. Not in AKS, what I have to do here is just go kubectl, scale, scale, -- replicas. So let's say I want 3 servers, equals 3. Deployments, / GDC, what was the name inside of here? Dash Minecraft. GDC-Minecraft scaled, and if you don't believe me, kubectl get pods will show you that there are now 3 Minecraft servers running instead of 1, and they are load balanced on my load balancing in the cluster. And for one last trick, if I didn't want to care about this anymore, what I might say, if I knew the CPU usage of my my particular application, I might say kubectl auto scale deployment GDC-Minecraft -- CPU %, equals 90% CPU scale, -- min equals 3, -- max equals 5, run. Of course, GDC. Of course. What it's going to want from me is this thing. 1 second. kubectl get deployments. It's probably named a different thing on this cluster, and that's my mistake. Nope, that's correct. The problem is that this one is already configured to auto scale because this is my dry run, and so I already completed that. There is one last thing we can possibly do here that will allow us to do this, which is to run up our Cloud Shell one more time. Ask kubectl what is in there. It should still be connected. We're live in the web browser. Five-node cluster. 3 pods running. And then hopefully, I did not auto-scale this one earlier. You saw me describe it, so all we're going to do here is kubectl, auto-scale. But we have to get the deployments. Yeah. Auto-scale. If this doesn't work, we're going to have to do it another day, but we're going to do deployment, GDC-Minecraft, -- CPU %, equals 90, -- min equals 1, -- max equals 3. In fact, let's do 10. All right, we can spot the typo.
Get.
What's that?
kubectl get.
There we go. No, it already exists. Unfortunately, that first. What's that? What's that?
How do you edit the auto-scale policy?
This was going to be, it's get HPA. So I could actually delete that if you wanted to. So they're called HPAs, horizontal pod autoscalers. So you can just do kubectl delete HPA GDC-Minecraft, since you asked. Delete it, and run it again. And that's how quick it actually takes to autoscale if you don't have a horizontal pod autoscaler available. Thank you very much for coming to my talk. That's how easy it is to deploy containers, clusters in the cloud for gaming, live in your web browser, in a bash shell. Thank you very much. We'll be running this talk tomorrow. If you're into containers, please hang on for Brian Peake. He's one of my colleagues from Microsoft in Redmond, focuses on gaming, who is going to be talking about developing your game specifically for using Azure Container Instances and Azure Functions as part of your game. Thanks very much, everybody.